How do we find eigenvectors? We need to do kernel of lambda I minus a, and we have to find it. True? In this case, we have that the lambda i's are plus and minus j. So we need to write kernel. We need to find the kernel of j 0 0 j minus identity minus a. Sorry, that means minus 1 plus 1. And we need to find the kernel of this stuff here. So equal to 0. In a certain sense, we need to solve this stuff here. True? This one, will it be real? For sure not. Do you see it? Find that v. Find the v. v1, v1, v2. Find something here, v1, v2, such that we get 0, 0. You should see it. I would say J1, true? J1. If I take J1, I will have this times this will do, oh no, sorry, minus J. Minus J. This times this plus 1, minus 1. True? You see, it gives 0, we together, and the same for the other one. This plus this is going to be 0. Together? I think so. I think so. It's 1j should be also correct, and in the complex play they should be aligned. It's kind of difficult to visualize those things because they are kind of complex stuff. Eigenspaces, change of basis. How do we find the change of basis at this point? We have v1 lambda 1, v2 lambda 2, okay? And we have to put them together. Let's do it. Here it is. Now, at this point, whenever we compute the transition matrix essentially is going to be this one, because it's going to be E dt t minus 1. I think I might have forgotten the slide to say it, or I might have forgotten to do the derivation. Let's do it. This one is equal to what? This one is equal to identity plus at plus a squared t squared 2 factorial plus etc. True? Then, perfect. This one is going to be t minus 1. This one is going to be t minus 1. This one is going to be, let's do it in a better way. This is going to be t minus 1, t minus 1. True? That means d squared t minus 1. A cube t cube. This one is going to be d cube t minus 1. Do you see it? At this point, all the left t's, I collect them. All the right t's, I collect them. And what do I get? I get that this one is going to be t e dt t minus 1. Together? How much are we together, people? 1, 2, 3. Excellent. In the complex plane, this stuff here, what is this stuff here? Isn't it something that rotates? And this stuff here, isn't it something that rotates? And if I put everything together, what will I get? This stuff here, isn't it this one? You see the two columns that go around and go around and go around and go around? Very much together, not at all, kind of. Good. Now, in a certain sense, at this point, this stuff here, we might also do it. This, you got the point. True. This one might seem a little bit more complex, but it's actually the same thingy. Let's make it on part. Let's make it. This is B, this is B, this is AAT, this is U, that is an input. I shouldn't be capitalized, sorry. This one should be U if I write this one. Because this one is vectorial, this is scalar. Anyway, I think it's because this one I was writing it in general. This object here is going to be times this, that is going to be equal to sine t cosine t. Okay? So we will have this object is going to be a vector. And this object here is going to be a vector made in this way. Sine t convolved with u of t and cosine of t convolved with u of t. Together? Are we together, people? 1, 2, 3. And if I was adding 7, 3, then I would have had here I would have had 7 cosine of t plus 3 sine of t, and this would be 7 sine of t, cosine of t plus 3 sine of t convolved, and here something else. You got the point? It's the same. Are we together? And of course, the convolution is linear, so I would get 7 cosine u plus 3 sine u. Together? You see it? And of course, on the second component, something different numbers, but you got the point. Okay? So this notation here shouldn't make you worry. It's essentially that we get some functions convolved. A vector of functions that are convolved with the u's. Okay. Do you see it? If I start in x0, that is this position in 0 velocity, it's essentially taking this object here. This object here will do something that is like bzzz, true? If I take velocity 0 position, it is going to be this one. It's still going to do this. I think in this verse or the other verse. Yeah, no, this verse. How do I get that it's this verse instead of this verse? Think about it. Would you choose 1, 2, or 3? You do not know. Go, discuss. What would you choose, people? If we take this object here, this is 0, 1 or 0, 2, but it's the same. I'm taking this column here. If I look at the components of those columns here in time, I will have component 1, component 2, true? In time, component 1 is going to do plus, component 2 is going to be plus, true? So I cannot be here after initial time. I have to be here, true? Do you see it? Are we together, people? 1, 2, 3. Okay? Let's do this one. I've got to think about it. What was I thinking whenever I was I don't like this question too much, actually. It's kind of written in a strange way. Uh, T0 equal to 0. Ah, no, no, sorry. So it's not T equal to 0, T0 equal to 0. Perfect. Sorry. My fault. My fault. So it's actually easy. It's very easy. Only written in a strange way. The solution is this one. True? Are we together? Main point that I'm trying to raise is this one with this question. This object cannot be outside because it's the h of tau. This object here is my h of tau. Okay? As the initial condition, I'm starting considering that the start time is at 0. Because if I was having this one, in a certain sense, we have to consider this one that is at starting at t minus 10. No. It's from t0 here, t0 to t0 to t. It's because of this one. Otherwise, it would be t0. Think of the convolution. Let me draw it because it's going to be more precise. U, H, T. If I have an H that looks like this one, and this is 0, what would you tell me about H? This one. What would you tell me about H? Not causal. Do we have physical phenomena that are non-causal? Actually, in Norway, we have one. Shaman Durek. Morten Pedersen yesterday told me this joke. I was really liking it. I don't know if he made the same. Anyway, are we together that this is kind of something that is non-causal? All the physical systems should be something like this. Okay? Then, whenever we consider U of t, very often from a control perspective, we assume also U of t non-causal. Causal. In the sense that we tend to assume that U of t starts at our t0. Because we start the experiment at noon, and somehow we put noon here. So this is our t0, and we tend to assume that our u's are going to look like something, I don't know. Okay. At this point, whenever you do the integral and you do the convolution, you've got to take this triangle and move it around, true? When are we going to have something? We're going to have something for the t's that are bigger than t0, true? And the integral, since we have 0 before t0 and 0 after t from a convolution perspective, the integral is going to be from t0 to t. This is somehow often why we have the integral within that way. Theoretically, it's from minus infinity to plus infinity, okay? That is formally what is happening. But whenever we have these u equal to 0 before t0 and causal h, this collapses in t0, t. How much are we together, people? Very much? Not at all, kind of. Other questions? I see a few tools. I would like some question, if there is some question.